Good morning, good afternoon, and good evening to those of us joining from all parts of the globe. Thanks for joining this webinar with us today, Building Java Microservices with Kubernetes and Quarkus. My name is Mike Jarrett. I'm with the Partner Connect marketing team, with the group that's sponsoring this event today. Before we begin, I want you to consider how technical a session you want this to be. If you're looking for more technology, that's great. Give a thumbs up and post that up as a question in the system. So give a thumbs up or +1 if you want more technology content. This session's for technology partners who are using Java or want to do more with Java. They want to get into more modern applications based on microservices, serverless architectures, and that sort of thing. So during the presentation today, we got two great speakers. Again, about questions, post them along the way. We'll set aside 5 or 10 minutes, if possible, towards the end to go through all of your questions. This session is being recorded, so you can share it with your colleagues after the fact, and give you also a chance to review it again. There are a number of material items, collateral items to access, including the session slides, that sort of thing. So feel free to download those as convenient. The two excellent speakers today, John Klingham, who's Senior Principal Product Manager for Application Services, and James Faulkner, who's Marketing Director for our Red Hat runtime products. So, with that background, let me hand it off to John, and he can get kicking off.
All right, thanks, Mike. I am going to share my screen here, and all right, here we go. So we've already kind of done the introductions, so let's go on and get started with the actual content. So the agenda for today, we've got kind of 4 sections to talk about. The first of all is the state of Java in the cloud, and then I'll get into some Quarkus fundamentals and some additional information around Quarkus. This is not, as Mike mentioned, like a Quarkus deep dive, but if you do have technical questions, great time would be Q&A, okay? And then James will be talking about partner opportunities for Quarkus and then tools and assets that are available for you. Okay, so the Java impedance mismatch. So if you think about the history of Java, right, it's been around for probably 25 years, and really during most of that time, the design center for Java was increasingly really for server-side Java, right, where you were running Java application servers, and the Java application server could be running dozens of applications, and so the way the JVM was designed was for these really large heaps with garbage collections of really large heaps. Applications were deployed in a highly dynamic manner because the application server wouldn't necessarily know what the application could do. So the application had to make a lot of decisions at runtime. So it's a highly dynamic environment. And really there's a trade-off there, right? Great throughput, highly dynamic, but it's at the cost of startup speed. Applications, being deployed to application servers could take a while. The memory consumption isn't necessarily a first-class concern because, again, application servers and even the entire stack from the JVM on, the app server, third-party framework in your applications just kind of assumed that you had a lot of memory at your expense, right? But now things have changed. They've kind of been flipped on their head, where we now have a cloud-native design center, where really our throughput isn't solved by vertical scaling. It's much more around horizontal scaling. The systems that we deploy to aren't highly dynamic at runtime, kind of like an application server is. Really what we do is we package our applications into immutable containers and deploy them to a orchestration runtime like Kubernetes and OpenShift, right? And so in this environment, really we want to deploy as many applications as possible on our cluster running within perhaps our private cluster, or if I'm running in the cloud, really I want to be able to fit my application in the smallest possible footprint because of cost considerations running in public clouds. Right, so footprint and performance, like things like startup time, where in Kubernetes containers are starting all the time, right? As you basically do your build pipelines and deploy to production multiple times per day, things like startup time really begin to matter. Right, so we have Java, the hidden truth of Java and containers. Java, as I kind of hinted at earlier, is not necessarily memory efficient. It was designed at a time, again, when most of the deployments were really on top of application servers. And the JVM has made improvements over the last 5 years for running in containers, but still you've got not just the Java Virtual Machine or JVM, you've got the third-party frameworks as well, right, that are designed to be highly dynamic, being deployed to an immutable system, right, which kind of feels a little bit odd, right? It's designed one way but deployed in a completely immutable system. So, compared to things like Node.js and Go, it is kind of relatively memory hungry, right? And the idea here is, right, for maybe a half a dozen HotSpot JVMs running inside of your cluster, you could, in that same footprint, maybe fit a dozen Node.js's and 2 dozen Go's, right? I'm just kind of throwing out round numbers. These aren't necessarily technically accurate, but you can fit definitely a lot more Node.js and Go applications than you can JVMs, right? And that's becoming kind of problematic when you think about runtimes or environments like functions as a service, like AWS Lambda, which is a really good sweet spot for things like Node.js and Go, but not so much for Java, because with functions as a service, really what you're doing is you're spinning up a JVM just to execute a single Java method, right? Not even an entire application. And what you do to create an application in a lot of ways, you combine a lot of these functions together, right? But each one of them is running on a JVM. And if you think about the memory utilization and the slow startup time, relatively speaking, for Java, it's not the choice that developers are making for AWS Lambda, right? Then they tend to go to things like Node.js and Python. But this is not just a functions as a service problem like I mentioned before. It really is just doing cloud-native development with microservices and cloud-native apps. So this is a user story that is on that link that you see below. I provided the link for user stories, and you can get a feel for what developers think about Quarkus. This is WePro Digital, right? Before they introduced Quarkus, many customers basically looked at alternative stacks like Go and Node.js because they weren't getting the efficiency and performance that they were expecting running in container environments. And this is reflected by a conversation I had at a Red Hat Summit with a customer that basically said, we had a mandate from management to reduce memory utilization because they were running out of memory and not using the CPU power that was available in their Kubernetes cluster, right? That the constraint was memory. And so they had to go off and look, and they were about to go, make a selection between something like Go or Node.js, and decided, hey, Quarkus was announced 2 weeks before they had to make that decision, and it really changed the way they thought about using Java because their developers are already Java developers, and they didn't want to have to retrain and retool their entire environment, retrain the developers and retool their environment just because of memory utilization problems. So that's where Quarkus comes in, where Quarkus kind of rethinks the problem for doing enterprise Java development. So Quarkus is an open source Java stack for developing cloud-native microservices and serverless, and even functions as a serverless applications, right? Where we take into account the problems that we've kind of encountered that I mentioned and try to figure out, okay, how can we make things more efficient at runtime? But also, another interesting tidbit is, developers are looking at things like Node.js because it's very productive, it's highly dynamic. I can do every change I make is kind of reflected in the browser, and I can do a lot more changes, a lot more iterations in Node.js than I could Java. So Quarkus, when we're thinking about how do we go and make Java kind of a platform that developers will use that's Java-based and cloud native, what are some other things besides just efficiency? And this is the interesting thing is this is to solve our customers' problems, right? Because our Red Hat is basically a Kubernetes and Java-based company, right? And so we want to make Java on Kubernetes a really nice, efficient solution and productive and cost-effective for our customers. And but we also wanted to do it for our own products, right? So to keep our own products that are Java-based in the middleware space, the Red Hat middleware products, the application services BU, we wanted to make sure that they would remain competitive running in the cluster against other products that might not be written in Java. Right, so we kind of are eating our own dog food when we were creating Quarkus. Okay, so to give you some ideas here when we're talking about efficiency, and this is an image that's actually on Quarkus.io, which is the Quarkus homepage. You can see this here, but to kind of walk you through this a little bit, if you look in the upper left-hand corner, it's a representation of memory utilization of a simple Hello World app. That's all it does is you kind of point your browser at an endpoint and it just says Hello World, right? And to do that with a traditional cloud native stack, so think Drop Wizard, think Spring Boot, think Thorntail, if you know any of those, right? It is basically to do that, it's 136 megabytes of RAM. If you take that exact same application running on the JVM with Quarkus, it takes roughly half that amount of RAM. And if you then compile it to a native binary, it can actually execute in 12 megabytes of RAM. So you can fit 12 natively compiled Quarkus applications in this particular use case. In this space, it would take one traditional Java, cloud native Java stack running on the JVM. Right? So very efficient memory utilization. Now, if you look at the bottom, it's measuring startup time. And by startup time, it's actually boot, so that the time to start plus the time to respond to the first request. Right? So and this is a CRUD application, so it's actually talking to a database. And it's very simple, right? Insert, update, delete database records. It's nothing more complex than that. And to accomplish that using, again, a traditional cloud native stack, it takes almost 10 seconds to respond to the first request. Doing the same thing with Quarkus takes, again, running on the just JDK, it's 2 seconds. Right? And if you compile it down to a native binary, and this is where people kind of get blown away, it takes 42 milliseconds to start. Right? And startup time, when you're thinking about clusters and functions as a service, Quarkus is now definitely a viable option for doing functions as a service. And even there's a great story by Vodafone. I don't have a slide on it, but if you go to user stories, you'll see Vodafone talk about how startup time really was a problem for them and determining the health of their applications because they were taking too long to start and so on. And startup time was a big difference maker with Quarkus for them. So when we thought about creating Quarkus, we didn't want to create this new framework, this new runtime from scratch that made developers learn lots of new things. It supports the standards and the best-of-breed frameworks that are available, right? So it supports MicroProfile, Kafka, Camel. We have Spring compatibility APIs for the popular Spring frameworks, not the entire ecosystem, but the kind of the most used ones. So if you're a Spring developer, you can pick up Quarkus and become productive very quickly. We support Vertex, kind of the Kubernetes-based, I guess you might say, specifications or standards around open tracing, open metrics. So we support a ton of frameworks. So we have we call them extensions, but basically think of them as just framework functionality. We have like 150 or 160 now extensions or frameworks that we support. And if you tack on Camel, which is an integration, enterprise integration collection of frameworks, it's over 300. I think it's like 300 or 350, right? So if you need to connect to any backend system with Quarkus, you could do that. So we support standards, best of breeds of the frameworks. If you're Java developers, they'll become very productive quickly with Quarkus. Right, now we have something called developer joy. So again, we Java developers were kind of envious of the Node.js developers, where we wanted to make sure that we could give the same high productive experience with Java that Node developers had with Node.js. So with Quarkus, we have a feature called live coding. And that shows, you can see the animated image here. Any code change you make is immediately available in the browser, right? So you go in, you can see here, changing hello to hi, refresh the browser, and it's available. And this is a very simple example, but you could add, if you're a Java developer, you could add Java functionality, Java classes, you can remove Java classes, you can even change your build configuration or your pom.xml file, again, if you're Java developers in the audience here. You can make changes to any of those, and Quarkus will automatically reload, and it happens so quickly that you don't really notice, right? So highly productive, highly iterative experience, and what's really nice about this, and I've had conversations with developers, and again, it's in the user stories as well. It's like, this is so productive that things that I couldn't try out in the past, I can now try out, which means I can be more creative in how I approach solving problems than I could be, pre-Quarkus, right? And this works with any IDE or no IDE, right? It's just a simple command line, and it just works out of the box. So no special tooling at all. And then we added something new in the latest release called the developer UI, or we shorten it to dev UI. And basically, you point your browser at an endpoint when you're running Quarkus in developer mode, the same mode that gives you the live coding, and you can basically get some additional information. So you can look at the configuration, change the configuration, and you see there's some boxes here. Arc is kind of our implementation for dependency injection, and you can take a look at information there. You can build a container image. You could look at the health of your endpoint just by clicking on the dev UI links that you can kind of see here in the box. And so every extension that we have, or again, framework that we have, has a dev UI component. A lot of them right now are just guides, and that's the little blue boxes that you see there in the bottom half of the screen. That'll just take you immediately to the guide. Right, so, but this is brand new, and we're adding lots of functionality to the developer UI. So if you're new to Quarkus, it's really cool. If you're an experienced Quarkus developer, it's a new feature in the latest release of Quarkus 1.11. Okay, so Quarkus provides two styles of development. Again, when we were building Quarkus, we were taking a look at what developers wanted to do, and really there's two styles of development that are that are super popular. Imperative has been around forever, and that basically means, when I write my code and I want to make a call to a backend service, I simply say call the backend service, I wait for a response, and when the response comes back, then I can continue with my business logic, right? So that is very productive, very easy to understand, very easy to debug, but it's pretty inefficient, because for every concurrent request you also have a thread. And thread take resources, both memory and compute resources. So if you want 500 concurrent requests, it takes 500 threads, right? Now, with doing reactive and asynchronous programming, Quarkus supports that style as well. And we try to make it as similar to the imperative style as possible, so you can kind of see these side by side where they're annotation based. But you can do completely asynchronous development and get basically lots of concurrent requests on just a few threads, so it's highly efficient in terms of performance and throughput, but also memory, right? And you can use both styles in the same application, if you want to, or depending on the needs of the application, maybe one is completely asynchronous, and for your traditional business applications that may not have high throughput, you just use the traditional imperative style. Okay, so I mentioned earlier that we support best of breeds and standards, but we're also innovating as well with the idea that let's try out some new things and see what the developers think, and maybe someday, depending if this really becomes something developers kind of flock to, then maybe we can consider standardization at some point in the future, right? But to get there, you really have to innovate first, and that's where Quarkus is really doing well. So I'm just going to point to two innovations here. The first innovation is Hibernate ORM with Panache. So this is a very easy to use layer on top of JPA, kind of a Java E, Jakarta E standard, with Hibernate as the implementation. So it just makes using JPA very easy. It provides, if you're a Spring developer, you may be familiar with the repository data access pattern. Panache provides that. Actually, Quarkus provides the Spring Data JPA API as well, but it's very easy to use layer on top of JPA. And another really interesting one that's brand new in 1.11 as well is something called REST Easy Reactive. And the idea here is, in the Java world, we have something called JAX REST. It's a standard API for doing RESTful development, making RESTful calls, responding to REST requests. And we have, with REST Easy Reactive, you get that same API, but it's under the hood, it's actually asynchronous. So you get that high throughput using the more imperative traditional style API that developers already know. And there's also lots of other really nice kind of ease of use extensions on top of that I just don't have time to go into, unfortunately. And you can see some of the other innovations. These are all available on Quarkus.io. Click on the guides link and you could read about these innovative APIs and how to use them and actually try them out. Okay, Quarkus is Kubernetes native, right? And you can see here, these are my top 10 Kubernetes features in my GitHub repo, github.com/jclinton. If you're a developer, you can go take a look at these and try them all out. But I'm only going to point to two for now. One is, in the top left, is one-step Kubernetes deployment with Quarkus. I can run a single command line and basically Maven package, and then I define a property that says deploy to Kubernetes, and it deploys to Kubernetes. Right? I don't have to do any configuration of any YAML config files, which is kind of like the configuration system for Kubernetes. I don't have to do any of that. I can do it. I can configure things using Java properties if I want to, and that'll customize the YAML that's generated. But it's just one-step deployment, one command. And the other really neat thing, if you remember that live coding with that animated image, you can actually do that with Kubernetes. So I can have my application running in Kubernetes, whether it's OpenShift or Minikube or any other Kubernetes environment. You can actually use your local IDE, connect to your server, your application running inside of a Kubernetes cluster, and do that live coding, and it'll just synchronize the code. It's super cool and fun and pretty darn productive. It's much faster than redeploying after every change, right? And there's lots of other really nice Kubernetes features because, again, Red Hat is a Kubernetes and Java company, and kind of making that combination as productive as possible and production ready as possible is a top goal. All right, Quarkus has got is winning awards. People are paying attention. Quarkus is quite popular. It's got we're darn near 7,000 GitHub stars. in almost 2 years. So we're doing quite well, and people are taking notice. So I just thought I'd point out that Quarkus is winning various awards out there. And I mentioned that we wanted to kind of eat our own dog food, right? We want to make Java productive and efficient for our customers, but we also, to remain competitive, want to do that for our own products. And so what this slide shows is that we have Red Hat products that are planning to use Quarkus. So that top row is upstream projects. So Keycloak, Cogito, Keycloak for single sign-on, Cogito for process automation, and CamelK for integration. Right? These are upstream products that we're kind of doing that, adding Quarkus support for that efficiency in developer productivity, and these will eventually make their way down into, well, these are the plans, right, to make them down into Red Hat products. You can kind of see those in that lower row. So I think we already have the integration API registry product is actually already running on Quarkus, by the way. So we've already done that, but we're going to continue to kind of try and roll this out. Okay, and the last thing I thought I would talk about is something called Quarkus Hub. So Quarkus provides, and I'm kind of out of time, I think this is like my last slide here. Quarkus Hub is a place where we host these Quarkus-enabled frameworks. So you can run basically any Java framework on Quarkus like you would, any other kind of Java runtime. But what's special about Quarkus frameworks, we call them extensions, and it basically plugs into Quarkus. So if you have a extension-enabled framework, Quarkus is a Quarkus extension. It lets you kind of tie into our configuration subsystem so that you can configure your homegrown frameworks, perhaps using the Quarkus configuration subsystem. It helps you compile to native binaries, right? So we're kind of building out this place where the community or even third parties can kind of host their extensions, and with that, you get things like automated publishing to Maven Central and automated inclusion in an extension registry that we're working on, so that all of our tooling can kind of pick up the extensions that third-party developers write, or community developers. Okay, let's see here. And we do have something called the Red Hat build of Quarkus, which is the productized version of Quarkus that is available, and that includes something called Mandrel. To do native compilation in the community, basically most developers use GraalVM, which is a open source project sponsored by Oracle, and they have commercial support. With Mandrel, we offer commercial support for native compilation. It's basically just a build of GraalVM for just the functionality that we need to do native compilation. We're not trying to fork GraalVM or anything like that. It's just to make sure that we can support it for the lifetime of Quarkus, of a Quarkus release, right? That's it. So any changes that we make to Mandrel for native compilation, we push back up into the GraalVM ecosystem, and anytime they have new build, we pull that down into Red Hat Mandrel. So you can get native compilation support for the lifecycle of a Quarkus release. All right, and that's it for me. And I think, James, you are up next, and I think I'll go on mute.
Okay, thanks a lot, John. So, hello everyone, James Faulkner, product marketing for Red Hat Runtimes. John talked a lot about Quarkus designed to take advantage of the modern deployment patterns that we're seeing with Kubernetes and OpenShift. So as you can see on the next slide, the great news here is that there is a big and growing market for both of these offerings. So both for application development as well as for the container platforms, PaaS platforms. We're talking multi-billion-dollar markets with projected growth. So these numbers you see on this slide come from a recent Gartner report that shows moderate growth rate for middleware. It's a more established market, but even 3 times the growth for the PaaS market in which OpenShift operates. So it really makes sense for Red Hat to combine and build a solid application development platform with Java and middleware as well as OpenShift. And it's even greater news for potential partners and existing partners to build bigger solution-driven deals as opposed selling, individual technologies. So on the next slide, we're in the Java space, and we believe the opportunity to work together really starts with the value that we are currently providing to our customers. So Red Hat has a huge Java EE, now Jakarta EE customer base. Really still remains very popular for enterprise applications, as it was designed and has a number of capabilities that businesses look for around security and fault tolerance and isolation and things like that, in spite of the many different alternatives in the Java space. So there's really a lot of opportunity out there for leveraging that existing customer base, along with the millions of developers, anywhere from 7 to 13 million Java developers who are familiar with Java EE. So customers have been using Red Hat JBoss Enterprise Application Platform, or EAP, for a number of years due to these benefits that they get and continue to get. So in addition to that, they trust EAP because it supports containerization, microservices, and hybrid cloud deployments. So in the EAP 7 family release, which was released several years ago, was really redesigned to be more modular, smaller, lightweight, and so it can support some of the cloud deployment platforms that we're seeing, or cloud deployment patterns that we're seeing, which also leads them to Hat also, because when they're moving to the cloud and they want to take these existing apps to the leading container platform with OpenShift, it really multiplies benefits they are already getting out of EAP and the rest of middleware. So even though Red Hat middleware can be used across these different footprints from on-prem to hybrid, using Red Hat with OpenShift is really a winning proposition for those bigger deals, those more strategic deals for the short, medium, and long term. So on the next slide, you can see that this benefit and this value really skyrockets with Quarkus. As John showed earlier, Quarkus provides Java developers with a familiar framework to create these bleeding edge applications, and it's familiar since it's still Java, uses a number of the very popular standards and frameworks out there today. So it's really never been easier to build a great modern Java application and really run them efficiently in the cloud with containers or serverless applications directly in Kubernetes. So this is really reflected in the advantages like faster startup time, lower memory footprints that John talked about, which translates to really enormous cost savings. If you read some of those user stories that John referenced earlier, you'll see a number of actual numbers behind the cost savings. We also have an IDC report later on that goes into more detail there. So this is really exactly what our customers need and are demanding for this new era of cloud-native Java application. So with Red Hat and its partners, market will continue to strengthen that foothold in leadership in the Java and Kubernetes space. So in the next slide, as far as specific opportunity numbers, the advantage partners get, not only from our technology, but from the solution providers who can really work with customers to build that solid solution on top of our innovative technology like Quarkus. And we've seen time and time again, Red Hat partners can really grow deals into multiples of subscription costs through services, ranging from deployments or maintenance contracts or on-site delivery support and so forth. So it also can translate into more powerful services that you can offer, consulting around application development. So on the next slide, you can see some of these numbers here. So $1 of subscription can translate to maybe $5 to $10 of services. For a 3 to 9 month project, that can translate to 100 to 2,000 days of billable consulting. So it's a very popular, it's very powerful mechanism to deliver those solutions, especially in this space for modernizing existing applications. So if you move on to the next slide, John, the one that's with professional services opportunity up. I think it's the next slide after the business opportunity slide. When looking forward, and specifically to the cloud, customers are really going to be doing one of two things. They're going to be either modernizing existing loads, so they're going to be wanting to move Java EE or EAP workloads to break them into smaller pieces and run them on new cloud-native runtimes and frameworks like Quarkus, for example. So the opportunity here is to offer these migration services with the help of things like the tooling we have with the Red Hat migration for applications, and a methodology for taking customers through that journey step by step. And we'll get into that a little bit later on methodology. The other thing, opportunity area for customers, is building net new cloud native workloads. So using cloud native runtimes and frameworks like Quarkus to build brand new or serverless based applications that will run as containers in platforms like Red Hat OpenShift. So the opportunity here, of course, is to then offer consultancy, technical and development services that really guide customers in creating these new cloud native application architectures, especially if they're coming from a traditional on-prem 3-tier Java EE application space, and they know that they build and transform and modernize, they're not going to know how to do that. And so that's where our partners can come in, implementing things like Red Hat Red Hat OpenShift, and then building DevOps processes on top of that to really supercharge that solution. Speaking of solutions, so if you move to the next slide, John, here's a snapshot. If we widen the technology aperture and think about wider than just application development with EAP and Quarkus or OpenShift as a platform, Red Hat is a really great choice because we have very wide support up and back, from bare metal deployments to advanced cloud and cluster management. So with Red Hat as a technology partner, you have access to all of these technologies, a lot of content about how these things get pieced together and how they can provide a true end-to-end full-stack solution for your customers and build that solid trust between you and your customers using the underlying Red Hat technology. If we deep dive a bit into the red box I have here on application server. So if you move to the next slide, this is an image that kind of shows the different capabilities of our Red Hat application services. It contains all of the different capabilities in the form of different products that enable them to cover every aspect of the application lifecycle, from development down to deployment and execution on the hybrid cloud or hybrid cloud. Specifically within our family of runtimes and frameworks, we provide leading open source application platforms like JBoss EAP for traditional Java EE workloads. We also provide support for cloud native frameworks like John mentioned Spring Boot, one of the most popular cloud frameworks today, and now also with Quarkus has really been described as the lightweight Java microservice framework, which kind of implies that things that came before it in the traditional Java space, things like Dropwizard and Spring Boot and others that John mentioned earlier, are the heavyweight alternatives. So it's and then all of that is then complemented by our leading enterprise Kubernetes platform with OpenShift, as our frameworks and runtimes that we build on top of OpenShift also are pre-integrated with them with a number of capabilities and features, such as the top 10 list that John showed earlier, how Quarkus integrates natively with Kubernetes and OpenShift. It's also worth mentioning that OpenShift late last year was just named by Forrester as the leader in multi-cloud container platforms. They do this Forrester wave that they do once a year, and so Red Hat is positioned as a leader in that report. So I know even further, and if you move to the next slide, John, we'll see that Red Hat has a lot of technology, but there's even more out there from our existing ISV ecosystem. So, for example, if your customers want the latest GPU support from NVIDIA, they're storing data in Mongo and only Mongo, maybe adopted Dynatrace and they're using for Java APM or application monitoring, or they're storing their Java artifacts and container images in Artifactory. We've really got you covered with the integration from a wide variety of ISV solutions that can meet those custom requirements, those custom customer requirements, and allow you to complete their solution with their preferred partners. So if you move to the next slide, some areas to probe with customers. Ask them about their existing application landscape. They're undoubtedly applications today if they're in business, and what to do. They're going to want guidance and consultancy from you to understand, look for moving those applications or transforming those applications to better increase business, their competitiveness or their time to market, things of that nature. Also ask them about their cloud and container strategy. If they're interested in moving to cloud and containers, you can of course bring it up in that discussion. But if they're not ready for that yet, we still have a wide variety of solutions for application development on traditional footprints like VMs or bare metal with our Red Hat middleware and with technologies like Quarkus. Also asking about their application strategy. What types of applications do they have today? What types of applications and custom requirements that do they want to meet tomorrow? Do they have special government regulations or security aspects that they want to incorporate into their application? How automated is their process, their CI/CD integration process? There's a number of opportunities to improve automation. All customers are interested in that. So when talking about and modernization initiatives, oftentimes they're going to want to know how much is this going to cost and how long is it going to take. So consider that when you're looking at building out your method. Also look at the availability of tooling, both from Red Hat or internal developed that you may be using. And then lastly, organization. How ready are users to move to something that's different as far as cloud solutions, or as far as moving from a traditional on-prem proprietary vendor to an open source? And then also ask them, how ready are they to transform their culture, their internal culture, how they build and applications to best meet the needs of their business and their customers as well. So these are some of the probing questions to ask to really get at what customers are thinking about when they're thinking about application modernization, and then applying the technology from Red Hat on our ISV partners to those problems to build out those full solutions. Okay, next slide. Just an example of one methodology. You may have your own methodology today, but this is we've used in the past. It's a proven example of really how a modernization and migration project can look like. It relies on standard, proven, modular, and most importantly, repeatable methodologies that you can apply to multiple customers. It also avoids the big bang approach where you just kind of say it's going to cost $12 million in an unknown time period. It really steps the customers through a iterative approach to modernization information by breaking the problem down through a number of steps through that methodology. And lastly, it all starts with that discovery session. So getting in front of customers, asking them the probing questions I mentioned earlier, and understanding their outlook on their application strategies is really important to not only understand the problem, but being able to present a solid solution for them. Okay, next slide. So just I'll leave you sources that you have available as Red Hat partners. So on the next slide, you'll Quarkus specific landing page for partners. This is on the Partner Content Hub. It is a one-stop shop, all things Quarkus. There's a number of customer presentations, which has a number of slides similar to the ones that John presented earlier. Customer-facing collateral like checklists and infographics and things of that nature. We also put what's new with Quarkus information. So we do a quarterly update, a video, and a set of slides that kind of talk about the latest innovations in Quarkus. We also have a number of demos and workshops that you can use in front of customers to build that confidence in your business, as well as build their confidence in the technology. We also have available trainings and sales kits. So if you move to the next slide, we have a specific one for RHBQ, which is the Red Hat build of Quarkus, a sales kit, which contains like an elevator pitch, a set of objection handling, what to do, what to say, what to show when, that kind of thing. So it really is a very easy thing to follow to understand how to talk about Quarkus in the wider context of application transformation. As far as training on the next slide, we do have 2 courses available today. We have a third one coming. These are available specifically and only for partners. These include foundational training for Quarkus, sort of what it is and how it works, as well as some more advanced, or what we call experienced courses that go into deeper dives into Quarkus and the way that it does its thing. And then we're working on a third set which goes even deeper, which will be an advanced course that talks about building extensions and really utilizing Quarkus to its max potential across the footprints that you're deploying it to. So on the last slide here, on the next one, John, more. So about I mentioned that IDC validation study. There's a link there. This is a great thing about with customers because it really showcases the value proposition of Quarkus, both in terms of footprint, memory and startup speed, but also developer productivity. And we put real numbers behind this. So we compare it to an alternative framework. We call it Framework A in the study. It's actually, if you look into the appendix, you'll learn that it's Spring Boot. But we're really showcasing Quarkus and its value to customers, its business value as well as the technical value. If you want to try it yourself today, you can go to the bit.ly link, try-Quarkus, and you can get hands-on immediately directly in your browser. You don't have to install anything. You get an OpenShift cluster, you get Quarkus source code, and then it steps you through the steps of making various changes and showcasing the value and features in Quarkus. And then lastly, if you want to build a new project and import it into your existing development environment, you can head over to code.quarkus.io to generate a new project specifying dependencies and a few features that you may want or need, and then you click a button and it downloads a zip file, which you can then extract and build using your custom IDE. So that's it for the slides. Thanks a lot. I'll pass it back to Mike now for Q&A.
Great stuff. John and James, thank you. I learned a lot here today. You mentioned the training here at the end, and that's exciting stuff. 16 hours of free learning for Quarkus. So we have a few questions that have come in. You can take a look at those, John and James, starting at the top of the list. One of the questions that came in actually for you, John, you mentioned, John, the GitHub link when you're talking about your favorite Kubernetes projects. So somebody's asking for that link. We can add it later on to the attachments. But if you text it over to me, and I'll put it into the announcement section. Next question after that: what's involved in getting an existing Java app / microservice running on Quarkus? Who'd like to take that one?
John, you want to take that one? You're muted.
Yes, I am muted. Okay. So to bring an existing application over, Java's broad, right? So if it's like a Java E application, just be aware that Quarkus does not implement, it's not Java EE compatible, but it does implement a lot of the APIs, right? So you got CDI, JAX-RS, Beam Validation, JPA, right? So most of the APIs that developers use, especially if you're using like the web profile. So it should just work as is with those types of applications, but just be aware there's like no EJBs, right? There's no JSF directly, but there is a community extension for JSF, right? So in the context of Java EE, there's a lot of functionality there. It shouldn't be too hard to move things over. A lot of developers do. And then it fully supports microprofile, so that shouldn't be a problem. And if your applications are Spring based, then we have the Spring compatibility APIs that developers can use. And if you read the user stories, some use that to bring their applications over, and some just bring them over and say, you know what, the JAX-RS and CDI and those kind of APIs are similar enough to Spring that I'll just adopt the CDI and JAX-RS. So it's completely up to the developer and what they want. The Red Hat application migration toolkit includes rules for migrating Spring applications over to Quarkus. So that's kind of neat. So take a look at that if you have Spring applications and you want to have them run on Quarkus. So I think that's probably an answer to that question.
Yeah, and so thanks, John, on that. I think the follow-up is the next one I'll queue up for you. For teams that are already using Java, what changes do they need to go through? Is it a compiler? Is it a VM? What else do they need to plan for that, making that change?
So for that, you need the things you really already have. You need Java. 8 or 11 is supported today, and I think we've got builds working on 14 and 15. And but in terms of staying on the well-tread path, it's 8 and 11. These days, I think most developers are on 11. If you want to compile the native, right, you don't have to, but it's kind of fun to watch your application start in milliseconds. Then you'll need GraalVM, most likely if you're running on a Mac or Windows. You'll need GraalVM. You can use either Mandrel or GraalVM if you're on Linux. So that's a separate download. And there's a getting started guide on Quarkus.io/guides that explains that. And then you'll need Maven or Gradle. Right, and that's really about it. You know, it'll work in any IDE, so pick your IDE. Doesn't really matter, and that's really about it. I definitely recommend taking a look at the guides, because the guides aren't just documentation. Here's what it is. It's also here's how to do it and use it, right, with like code-led examples. So definitely take a look at that. I hope that answers the question.
Hey, Mike, you're muted.
Never happened before. Thanks for that. So, at least not in the past hour. Good. Thanks, John, on that. James, did you have any questions that you're looking at the questions, I assume? Yeah. Otherwise, I'll throw up another one for John.
Yeah, there's a couple of these I think I'd like to tackle. So the first one is, can you talk about the process required for including a non-supported third-party library that doesn't currently have a Quarkus extension? Is an extension required to use it? So the answer is no. You don't have to have an extension to use an existing third-party library. One of the features of Quarkus is that it's still Java. You can still build traditional Java applications that deploy to a traditional JVM like HotSpot. And you can use those third-party extensions in the same way that you've been using them in the past. Now, if you then want to take that additional optimization step and build a natively compiled binary, that's when things get interesting, because there are some assumptions made by Quarkus and by the native compiler that it can figure out what's going to happen in the application when it's being built. So if you use things like reflection or dynamic class loading, or you're using a framework that happens to use those, then those you would need to declare what the framework is going to do dynamically at build time, so that Quarkus can prepare for that at runtime, so they can support that native compilation. But again, you don't have to take that path. If you have a third-party library that simply does not work in native mode, you can continue to use that and still get the benefits of the framework optimizations that Quarkus is doing without doing the native compilation with GraalVM and Mandrel. So then the other question I saw is around Spring, and it said...
hey, James, can I add one thing to that?
Yeah, go for it.
Yeah, so there are user stories. If it's not in the stories, it's in follow-up conversations where organizations, once they start using Quarkus and they want to be able to compile native, they write their own extensions, right? So their frameworks can plug into the Quarkus, build time capabilities, so they can compile the native, so that they get integration with Quarkus configuration. And add a dev UI box if you want, right, or a quick start. So So Quarkus, when you generate an application, could lay out code predefined, and you could plug into that. So there's lots of things that you can do. And so definitely, if this is an area of interest, this is a separate, we can have a follow-up kind of thing that talks about how to write Quarkus extensions.
For sure. Okay, there's two questions that are basically, I think, very similar about replacing Spring Boot. So first one question is, does Quarkus replace Spring Boot or Tomcat for our Spring-based services? And the second was, do we need to rewrite Java/Spring Boot code if we want to migrate to Quarkus? So first I'll mention the Spring compatibility APIs that John talked about. So Quarkus does implement a number of APIs from the Spring ecosystem, like Spring Web, Spring REST, Spring Security. I believe Spring Batch is close to, if not available, and a few others, very commonly used ones. So you'll be very familiar with Quarkus if you're coming from a Spring world. So you don't necessarily have to rewrite depending on the third-party extensions you're using or things that you're using from the Spring community. I also added a link to the chat to a recent blog post that was just released. I think it was yesterday. Yeah. So it's an interesting use case of taking a Spring application and quote-unquote porting it to Quarkus with zero changes. So that's a very powerful message when talking to customers about if they're a Spring shop and they're interested in Quarkus. You can kind of show them that yes, Quarkus can. It's a very easy migration from Spring Boot. In some cases, it's zero. In most cases, there'll be some small things you need to change, but the vast majority will be very minimal. And the fact is that if you're building and using Spring Boot, you are probably building microservices, and that's really what Quarkus was designed for. So you don't have to go through the modernization of an existing Java EE app over to Quarkus if you're already coming from somewhere that's already been sort of microservicized, which kind of touches on one of the other questions about migration from WebSphere Liberty to Quarkus. One thing to note is both of those implement microprofile, and John, maybe you want to talk a bit more about microprofile, but if it's a microprofile based app, you're going to have 100% compatibility with Quarkus in terms of the APIs.
Yeah, so Quarkus fully supports, all the microprofile APIs, including there's the core platform for microprofile and a bunch of standalone specs that aren't part of the core, and Quarkus currently supports all of them.
Good. Thanks, gentlemen. So we got about 5 more minutes for folks to keep. We have a bunch more questions to go through, which we'll keep on doing. So anybody that has other questions, this is your probably last chance for it, last call on that. Before I hand it over back to Jim and John, shout out to Cheryl D., who I used to work with quite a long time ago, and I saw your name participating. So hi, Cheryl. Good to talk. Good to see your name again. Okay, Spring Boot REST versus Quarkus. James, you talked about that a little bit. Is anything more to say there?
Actually, I think I'd ask John to cover that. He's more down in the REST area.
Good.
Yeah, so we have compatibility APIs for Spring MVC. So there's a guide. Actually, there's guides for each of the compatibility APIs. So just off the top of my head is MVC, Spring Data JPA, Spring DI, Spring, Cache, Spring Security Annotation. That's not the full Spring Security capabilities, and I'm missing some, right, just off the top of my head. There's like 6 or 7, compatible APIs, and we try to hit kind of the 80-20 rule, right? What are the ones that people use most, and let's provide compatibility for that. So again, make it easier to learn Quarkus. It's not really intended to be, let's migrate my, full-blown Spring apps over to Quarkus, right? Now, people have done that, and they've done it successfully, but sometimes it may require picking up a Quarkus API or a microprofile API or something like that, right? Like we don't support Resilience4j or Hystrix, but we do support microprofile fault tolerance, right? So the capabilities are there, but you might have to do some API mapping for that. And each guide will tell you which annotations are supported for that API, right? So Spring DI has, auto-wired and stuff like that. And Spring Web MVC has Spring MVC has at Git mapping and at REST controller and stuff like that, right? So again, you can it's the 80-20 rule kind of right now. I think that probably answers that question.
Okay, yeah. And I see a couple of others I'd like to hit because I think they'll be quick. So the first one is, it's being said that Quarkus is optimized for lower memory usage, but it is Java-based, which is resource intensive. May you explain that, please? So the thing to understand about Java, Java itself is not memory intensive. What's memory intensive are the frameworks that are built on top of it. Those frameworks do a lot of things, traditional frameworks do a lot of things at runtime that's where the memory comes from. So things like initializing a sprint, dynamically loading beans into the VM, doing things like building meta models for accessing databases and building ORM mappings and things like that. All of that happens traditionally at runtime, which takes memory and time, and that's memory that you don't get back, right? It's part of the framework initialization, and it stays around forever. So with Quarkus, it does all of those optimizations at build time. It makes those connections at build time, and then essentially saves that state. It's not a snapshot, but it is a high performance index where those connections between library and business logic are made at build time and remembered, so that at runtime, number one, it starts up very fast because it doesn't have to do all that dynamic linking, and it also takes up less memory because it doesn't have to build those meta models that it's already built and optimized at build time. And furthermore, if you're doing native compilation, it's also eliminated a lot of the code that will never be visited, what we call dead code. So that's really where Quarkus shines. Is it takes the traditional framework approach of runtime dynamicity, if you will, and turns it on its head and does that at build time. So you get a very fast startup and low memory usage as a result of that.
We can do one very short one, if you want to take a try here.
Yeah, I'll do the last one actually, because it's part of the runtimes around EAP. This isn't specifically an EAP talk, but the question is, Red Hat's usually excellent support really seems to struggle with configuring and troubleshooting EAP on OpenShift. Is Red Hat continuing to invest in EAP at all? Are there upcoming changes to make it easier for customers and support to manage? So the answer is yes. EAP continues to evolve. The next release of EAP will be 7.4. There will be a beta release of that next month in March, and then a GA is targeting for May of 2020. And it's going to bring in a number of new capabilities, especially around OpenShift, with things like the EAP operator. There's a Kubernetes operator for deploying and managing EAP, and it exposes a lot of those traditionally difficult to configure things like data sources and other aspects of EAP as an EAP operator with custom resources. So instead of writing an XML and dropping it into a directory on a running server, now you create a custom resource in Kubernetes, and it will magically pick that up and be able to configure that based on the definition. And if you want to get rid of it, you simply delete the Kubernetes resource, the custom resource, and it goes away. So that's kind of the strategy behind operators in general, and we're applying that to EAP as well.
Great, thank you very much. We're out of time today. Great session, gentlemen. Thanks for your time. Lots of great questions. So thanks everybody out there for joining us, and enjoy Quarkus.